Okay, students. So far, we have discussed what is mean by the transaction. What is mean by the transaction? We have seen through the examples. Next, we have discussed what are the various acid properties. So, as we know, acid stands for the atomicity, consistency, integrity, and durability. From this point, what we have to do, we have to understand the concept with the different way. But what we have discussed yesterday, yes, we have discussed the schedule. This schedule is required to understand we can do the concurrent execution or parallel execution of the transaction can be happen. So from this perspective, we have to understand the concept step by step. So today we have a topic concurrent execution and with conflict serializability. So this conflict serializability we will see in detailed manner, but let us understand what is meant by the concurrent execution. So why do you need concurrency in the transaction? This is a word we have to keep in mind while learning the database management system. So a database basically is a shared resource access. It is used by many users and processes concurrently. So for example, the banking systems, railway and air reservation system, stock market monitoring, supermarket inventory. So there are lots of the places you can use this kind of a feature that is a concurrent execution of the systems or concurrently execution of the process. Like simple example on the Gmail server, multiple users are communicating each other. So they are executing, they are passing, they are sending or receiving the mails concurrently simultaneously at the same moment. So this is a real kind of application we can have. But if talking about very lower level in industries or in an industries and a banking system, railway now, so on the same time you can book the ticket, or your friend also can book the same time the same ticket from the same coach, same rail, and same train, same route. It is also possible. So simultaneously the database we are accessing. So we are not the only alone person. We are accessing the same database. There are n number of the person they can access the same database. So at a time, concurrent execution is important part. So not managing concurrent access may create the issues like hardware failure and system crashes. So you must be keep in mind when you are talking about the this concurrently execution, your hardware should be strong to manage the multiple process at the same moment. That is necessary point. So concurrent execution of the same transaction deadlock or slow performance. That is reason. So concurrent execution of the same transaction if you're doing, so deadlock may occur. Because at that moment multiple processes are coming at the same time, so collision may occur. So to avoid the collision, there are some deadlock avoidance, deadlock prevention algorithm as we have discussed in the operating system. So that is the reason we are talking about the multiple process we are having. So system will be slow automatically because it provide the slow performance. It's a normal thing on your laptop or your desktop. If you are opening the multiple applications or your mobile, you are opening the multiple applications. So your mobile will go on the slow performance. So it's a normal thing in the electronic devices. So that is the reason. But why we have to use? So the reason is clear because the multiple transactions or multiple processes are executing simultaneously. So it is also happen in the real world situation. Those are the banking system, railway, and air reservation, stock market, and there's so many things. So equivalence. So from this point, we have to understand the point serial schedule. So what we have discussed so far, if you remember the my words in the schedules, we have discussed the T2 or T1 or T1 or T2. So this is what T1 after the T1 I'm executing the transition T2 or after T2 I'm executing the transition T1. So this is what this I'm just following the serial. So what is the things we have? So this is the result can be these are the two different schedules of the transaction T1, comma T2 or T2, comma T1 if giving a same result, then we can say it is equivalence. So result can be equivalence over here. So just listen the first point. Equivalence we are understanding. So equivalence in terms of the scheduling equivalence. So if two schedules display the same result after the execution, it is called the result equivalence schedule. They may offer the same result for the same value and a different result for another set of the values. So this has happened in the our previous example. If you remember yesterday's class, we have seen. So for example, in the one transaction update the product quantity and while other update the customer detail. So that is the happen because one transaction is trying to update the product quantity and the other is following by the update the customer details. So multiple transactions are executing simultaneously. It is happen, but that is the point we are getting the something properly. Now here we have the equivalence can be divided into the two normal part. One is the view equivalence. So in the view equivalence, what we are saying, view equivalence is saying to us, view equivalence occurs when the transaction in both the schedule. Here we have the two schedules. What are the two schedules? Just you can understand. Just I'm marking by the circle way, so you can easily see. This is the first schedule. This is another schedule I can give. So here, what I mean to say that here we have the two schedule S1 or S2. I can say in a normal way. So view equivalence occurs when the transaction in both schedules perform a similar action. That is the point. For example, one transaction insert the product details in the product table, while another transaction insert the product details in the archive table. So the transaction is the same, but the result are but the tables are different. So transaction is the same, but tables are the different. So we can do. So here we are getting the view equivalence. But what is conflict equivalence? So that is the point in this case. In this case, to transaction update or view the same set of the data. So if I try to update the simultaneously both things, so it will not be happen. Just like example, I'm remembering example. If you try to update some account balance by adding the 50 rupees, and the same time you are just trying to withdraw the 50 rupees. So at a time, that is a big point we have over here, which part will execute first. So to avoid the such thing, we have a schedule. The schedule is really important over here. That is the point from which we have to understand the conflict may occur. So to avoid the conflict, we have the another terms we will see step by step. But first, we have to understand why concurrent education is required. So to this from the conflict equivalence, we have to understand the concurrent education. So equivalence can be the three types as we have seen the yesterday class. As I told you, conflict can be of the three types. So conflict equivalence is saying to us in this case, two transactions update view of the same set of the data. So there is a conflict amongst the transaction as the order of the execution will affect the output. So if you remember the my previous example, what we have calculated, X was the 165, Y was the 165. But after changing the different order, after having the different order, I was getting the X equal to 160 and Y was the 170. So what is the result? The conflict equivalence is saying to us over here. By the S1 table, by the S1 schedule, I'm getting the X value in different value that was 165. While talking about the S2, so I was getting the X value 160. So that is a big point we have to keep in mind properly. So in this case, two transaction update view the same set of the data. So there is a conflict among us transaction as the order of the execution will affect the output. So here we have the conflict transaction, conflict equivalence. View equivalence is just saying nothing. You can view the only result only. So from the both schedule, you are just able to see only details on this, but you are not trying to update. You can get the different tables or from the different table, you can get the same result and what you are having the equivalence. Now, is it clear to all right now? In the result equivalence, we have the two type of the one is a view and conflict. You can understand this one right now. Now, is it clear to all right now the equivalence? We are expanding our lecture by the previous class what we have seen. So from our last class observation, we are just continuation of our previous class. We are just looking at the equivalence. So as we have discussed, there are three type of the equivalence. So what are those? Result, view, and conflict. Now it is clear to all right now. Yes, tell me. Is it clear to all?
Yes, sir.
Okay. So let us understand the concurrent execution from the starting. Do not think about the right now arrow. Just let T1 and T2 be the two transactions. From this point, you people are required to take care of the concept properly because your next tutorial will be depend on the this kind of the question. So focus on the concept properly. So let T1 and T2 be the two transactions that transfer the fund from one account to the another. Transaction T1 transfer the rupees 50 from the account A to account B. So it is defined as the focus on the concept. I now look at the arrow now. So T1 just is a transaction which has a read A equal to A minus B, write A. So what I'm doing right now, I'm trying to update the value of the A. So what it will have, A will be updated by the subtracting 50 rupees. Okay. And now B. Now I'm reading the B account detail. So I'm adding the B, that is the B equal to B plus 50. So now the 50 rupees from the A will be transferred here. Okay. So now here we will get this value and write B. So this is the point. Second point. Transaction T2 transfer the 10% of the balance from the account A to account B, and can be defined as, now look at the arrow. Transaction T2 transfer 10% amount of the balance from the account A to account B. It is defined as T2. That is transaction 2. T2 is just read A. So temporary variable I'm taking, I'm just getting the 10% amount of the our temporary value. So that is the temp equal to A into 0.1 and A equal to 1 minus A minus 10. So I'm deducting the 10% amount of the A and transferring into the B and writing A. So I'm writing A, it means the value which are having by the A will be updated, that is deducted amount. And now I'm reading the B, and B equal to B plus P plus 10. So temp value, just hold the 10% amount of the A, and that is to be added over here inside the B. So now it is clear. So writing the B, it means I'm updating the balance of the B. So what you are observing over here, we have the two type of the our operation, read and write operation I'm using for the transition operations. So with the help of the transitions operation, I'm just writing the two different transition. One is T1 and T2. So is it clear to right now?
Yes, sir.
So here we have the two transition T1 and T2 can execute simultaneously. So we can get the update the details properly over here. But here the point is that over here, if T1 and T2 I'm using T1 then T2, it means after the T2, if I'm trying to use the T1, so result may change. If I'm using the T2 first or T1 first, depending on the thing, so result may change. You have to take care of this point. Now, let us understand the concept properly over here. Now, this is a solved example, and this is the point we have to keep in mind. This is the serial schedule. T1 is followed by the T2. Please focus on the concept properly. In the concurrent execution, we are using the our schedule 1, that is a serial schedule. That is a T1 is followed by the T2. So first T1 will execute and then T2 will execute. Okay. So read A, B I am doing over here. So I am just putting the both transaction in a specific way. So this is example diagram T1 and then T2. So now you can see, observe over here. The example is written over here. Suppose the current value of the accounts A and B B are the 1,000 rupees and 2,000. So suppose also the two transactions are executed one at a time, the T1 and then T2. So this execution is a sequence appears in the diagram as you can see over here. So in this diagram, the sequence of the instructions step into the chronicle order from the top to bottom. That is the point you have to keep in mind, top to bottom. So from the transaction T1, all the instruction of the T1 will execute first, and then all the instruction of the T2 will start to execute. So after the T1, the end of the transaction T1, then transaction T2 execution will start. That is the point you have to keep in mind. And the final value of the A and B after the execution will be the rupees 855 and rupees 2145 respectively. So how you are getting, as we know what you are getting. So here I am reading the A equal to 19950. So how I'm getting? How I'm getting? Because A was the 1,000 rupees and 50 was deducted in our previous transaction. So in the transaction T2, if I'm reading the A, so what I can get A equal to the 1,000 minus 50, so I will get the A equal to 950. Now it is clear in the transaction T2 how I am getting the read A value 950, because it was updated by the transaction T1, that was a 1,000 minus 50. Now it is clear.
Yes, sir.
Okay, so now I'm getting the temporary value of the 950. Please keep in mind, I'm getting the temporary value of the 950. So what I'm getting, that is some amount I'm getting. So can anyone tell me what is the 10% I'm getting? 95. So 90 temporary will hold. Just you can observe over here. Temporary will hold. I can write over here. Temporary is a variable which hold 95. Temporary will hold the 95. And what is this? Which is 10% of 10% of A, which is 10% of A. So in the temporary, you can see, so A is equal to the 950 minus 95. So I will get the 855. So after writing A, so I will get the A equal to 855. And read B. So I am reading the B. So that is 2050. Why? Because 50 was added by the transaction T1. So same thing will be happen over here. So 50 was added over here. So but 50 was not added over here. 50 was added to the B only, but temporary value inside the B in the transaction T2 was added. So 2050 plus 95. So I will get the 2145. That is simple case. So this is the order of the transaction T1 and T2. Now it is clear. The serial schedule is saying to us first transaction T1 will execute, then transition T2. Or if you can put the T2 first or T1 then next. So if I'm changing its order, T2 first and then T2, T1, T2 after the T1 or T2 after the T1 or T1 after T2, so definitely the result will change. That is the point. So you have to keep in mind which is the transition you are taking the first. Let us instance. If I'm using this one, so you will able to see, now you are able to see in the schedule 2, I'm altering the change. I'm executing the first transaction T2 and then transaction T1. So what I'm getting? I'm getting the A values 850 and B's value 2150. And previously A was the 855 and B was the 2145. Now this is clear to all right now. The serial schedule is saying to us which order you are picking first. So serial order in the serial order, you can take T1 first or T2 first. It's a choice, but result will change. Okay. So in the examination, you have the order will be given. Then according to the order, you have to solve the problem. So, but right now, let me know the status. Is it clear to all? The concept is clear to all.
Yes, sir.
Yes, sir.
Okay. So this is the most important point you have to keep in mind for the gate examination. If you are missing the single statement over here, then you can't able to understand anything. So focus on the example. That's why I've taken only the simple example to explore the idea. Now let us move to the next part. What we have written.
Uh,
Yes, tell me.
so in examination, we have to calculate the final values of A and B, right?
It could be, or maybe the some advanced level of the question can ask. So this is only the beginning or just fundamental question, but we have a lots of the concept right now. So see, okay, wait, and we will have the some different concepts. So definitely the in the examination we will try to focus on the hot questions. So based on the hot questions, so definitely the level will be next level question. Okay, don't worry. First understand the concept, and then you will ask me which kind of the question I can ask into the examination. But this is a fundamental kind of the question. If you are not known to the point, then definitely you are not able to solve any question which are related to gate examination. In the gate examination, the question will be asked in the gate in the simple pattern only. But we don't know the fundamental part that how we can able to solve. So first try to understand the fundamental concept. Then you have to final calculate the value. So this final calculation value is not our objective. Our objective to learn the concept. If maybe the complexity I can enhance. So this is the first kind of the schedule you are observing. That is serial schedule. Okay, just wait. Okay, we have another concept right now. But this is a fundamental point right now. Is it clear to all right now?
Yes, sir.
Okay.
Yes, sir.
Okay. Okay. Good.
Yes, sir.
Good. So this is the point you people are required to speak, or you have to learn this point right now. So I have given this point over here. That is summary what we have discussed. So the education sequence just describe or called the schedules. So the schedule means what is the order of the transition we have, that is to be determined by the schedules, and inside the machine what is the algorithm. That algorithm is known as the scheduler. So they represent the chronicle order in which the instructions are executed. Instructions means statements, operations, or the task, a set of the tasks what I have written over there, which are executed in the system. Clearly, a schedule for a set of the transactions must consist of all instructions of those transactions and must preserve the order in which the instructions appear in each individual transaction. So what is the order you are picking for the executing your transaction? So based on the transaction, the values will be updated. So we will use updated values from the previous transactions. For example, in transaction T1, the instructions write A must appear before the instruction read B. So that is the point. Before reading B or reading A, we have to keep in mind what the order we are picking. So that is the read and write operation. So write operation is just writing the information to the disk, and read operation is reading the data from the disk. That is the point you have to keep in mind. Yesterday we have seen. So in any valid schedule. In this our following discussion, now you will see, you have seen, okay. So this is the point you have already discussed. So we shall refer to the first education sequence T1 followed by the T2, and as a schedule 1 we have seen, and to the scheduled education sequence T2 followed by the T1. So that is schedule 2. So we have the two schedules, one is schedule 2 and schedule 1. Schedule 1 must be clear to all right now, that is the T1 followed by the T2. Now, in the second schedule 2 is saying to us T2 is followed by the T1. So that is the point you have to keep in mind. This is a summary. So this is to be identified by the schedulers only, or schedules only. Now let us see this point. I have changed something over here. So far, I have been observed the schedule. That schedule is known as the serial schedule. But here, I'm using a different kind of the schedules. Let me explain. First, I'm using the T1, then T2, and then I'm using T1, and then I'm using the T2. So what is the my order of the accessing the value? So T1, T2, T1, T2. Okay. And from this point, you have been observed over here, the transition T1 was not complete. First T1 was complete partially, then T2 was also completed partially, and then T1 also completed the rest of the part, which is the part of the transaction T1 was complete first, and then T2, the remaining part of the T2 transaction will execute first. So that is a point you have to keep in mind. Let us understand this point right now. Read A, read B I'm using. Okay, so first I'm reading the, just please focus on the my return statement or in the blue, red color and green color. First I'm reading the A value. So A equal to A minus 50. So what is A value? If you remember, 1000. So now A will be having the 95. So just focus on this point. Now in the next point I'm executing the transaction T2. So what I'm using, I'm just switching into the transition T1 to T2 before ending the transaction of the, or before completion of the transaction of T1. So this is known as a concurrent execution. In the concurrent execution, what I'm doing, I'm switching one transaction to another transaction, and then before ending the its transaction of previous transaction. So this is a concurrent execution, and this kind of the concurrent execution will be applicable over here. So such schedule is known as the concurrent schedule. Okay. Now T2, so T2 will get a value. Okay, it's a temporary value. So a into a 0.1, 10% I'm using. So 10% value I'm getting. So what it will have? It is the value I'm getting the 95 over here. Now transaction T1 and T2 is completed. Now after that, these values, now T1. So now in the next, I'm using the T1. So I'm going back to the T1 for completion of the remaining, for execution of the remaining set of instruction. You can say read B. I'm reading. So I'm reading here, and what is the B value? 2000. So B equal to B plus 50. That is the 2 B equal to the 2050. It will be. final value, because after writing the B. So in the next T2 part, remaining part of T2, so I'm reading the B. So what is the B value of the, you will say, sir, T2 will use the B value 2000 because it is a different transition. No, from the disk we have updated the value of the B, which was a 2000 updated by the 50 value. So it would be the 2050 because we are adding the 250 rupees to the B's account. So we are after writing the B, after using the write operation on the B. So if you try to read the B next time by the any one of the transaction, then it will be read by the 2050 only. So that is the point you have to keep in mind. So this is to be done by the read and write operation. So before writing, you are trying to read, then it will determine the same value. But after writing, it will determine by the updated value. So read B I am using right now. So what it will say, you are using the 2050 rupees. Now I'm adding the temporary value. So if I'm trying to add the temporary value, so it was already calculated by the temporary variable of the transaction T2. So what was the data? 95. So I'm trying to add, so I'm getting the 95. So B will becomes the 2145. After using the write B operation, so final value of the bill becomes the 2145. So that is a transition. This is known as a concurrent schedule. So first I'm using transition T1, then T2, and then T2 to T1, and then T2. So this is transaction is on a concurrent schedule transaction or concurrent scheduling, because what I'm doing using the context switching. I'm switching one transaction to another transaction and then coming back, and then it is happening. And it is also happening inside our operating system while discussing the algorithm, so many algorithms, the process scheduling. Because one process is not complete due to some time of the period in the round robin algorithm. In the round robin algorithm in the operating system, we will use the context switching because the time stamp is given to the process is very high. So depend on the its availability, the it wait for the some it will goes into the waiting state, and then other process who have the less time, then or less time stamp or less time slice, so the next process will be executed. So this is the inspired by the our round robin algorithm in the operating system. Then first come first serve, that is to be followed by the schedule. Okay, so this is two things. Now, is it clear to all right now the concurrent execution? What is happening over here? Now it is clear. What is the final value of the A and what is the final value of the B? Okay, so now it is clear.
Yes, sir.
Okay, anything you need to ask here? So please you can ask. Anyone who need to ask any question over here? No. Okay, so I'm moving back to the my previous slide. So what we have discussed so far in the concurrent execution, we have discussed the schedule and concurrent schedule. Now moving to the next schedule. In the next schedule, we have next concurrent schedule we have, that is the schedule 4. Here what I'm using. This is the point we have to keep in mind. Theory portion I'm not reading. Theory portion I'm not reading unnecessary because I've given over here only for notes purpose only. So transition is transition will be in consistent state. Let us understand how. T1 I'm using in the transition T1. I'm reading the A value. So I'm getting the A value 1000. I'm just deducting the 50 rupees. So A will be the 950. You will be say, sir, okay, I'm getting the 950. But after some time, I'm switching to the transaction T2. So transaction T2 will try to read the value of A. So what it will read? You must say, sir, it should be 950, but no, it should not be. Why? Because I didn't use the right operation on the A, so that's why its value was not updated. So it will, if you try to read the A value by the any one of the transaction, then it will calculate or it will use the 1000 rupees. That is the point you have to calculate it. You have to keep in mind properly. Temporary value I'm getting, so it will give the 10% of the 1000 value. So what I'm getting the 100 rupees. And now I'm just subtracting the 100 rupees from the A's account. So what I will get, I can get the 900 rupees. So as it is already mentioned over here. Now write it. So from this case, I'm just trying to write A. Okay, so I'm trying to write A. So after writing A will be the 900. Now after in the same continuation of the instruction, I'm just trying to read B. So what I will say, it will say B will be read by the 2000 rupees. So I'm reading the 2000. But suddenly I got a message and I'm just switching from the transition T to transition T1. Now after jumping on the transition T1, so what is the next section? We have the write A. So from this write A, you have been observed over here. What is the previous value of the write A? Previous value of the A. You should keep in mind, sir, in this transition T1, we have been observed it should be 1000, and after reading the 950, so right after performing the write A operation, it should be 950. No, what was the last value or will be accessed by the what is the last value of the a value of last value of the a accessed by the any one of transition, that was the 900. So if I'm using the write operation, so by default it will write the 900 to the memory or disk. So writing a you can use, so it will write the 900. So what is the previous value 900? So it will just overwrite to the 900. So there will be no sense, but it will write only the 900. Now here I am reading B. So what is the read B? So read B will be the 2000 only, because I didn't update anything on the B account, and I didn't use any kind of the operations. So after reading the B, I will get the 2000, and after adding the 50 rupees, so what it will be? B will be the 2050. Here I am using the write operation. So after writing the B, final value becomes a 2050 so far. Now when you just move to the B equal to 10 plus 1, so what it will do? What it will do? Can anyone tell me right now what it will do? I have already mentioned over here.
It will add 100 rupees.
100 rupees to 2000 rupees or 2005 2050 rupees?
So 2000.
No, it should be added to the 2000, or it should be added to the 2051
Sir, 2000 rupees.
2000. Why 2000? Because in this transition T2, it was read the value B that was stored into the memory, that is 2000 only. So in the transition T2 was not write anything on the B value. So because we are not reading, suppose B equal to B plus 10, if you're trying to read B again, then it will read the 2050 rupees, 2050. But it was already read by the B by the transition T2, so it will keep the this B value into the memory, that is 2000 only. So we are performing only the arithmetic operation over here. B equal to B plus 10. So it will 50 was the temporary variable, that is the 10% amount of the A will be added to over here, that is inside the 2000 only. So B equal to 2000 plus 100 will be, not the B equal to 2050 plus 100. That is the point you have to keep in mind. If this is a point you have to keep in mind, there is a condition. If we are using the read B operation again before B equal to B plus 10, then B will be considered as a 2050. But it is already read by the B operation by the transition T2 before writing the B. So before writing the B, transition T2 already read the value of the B, and that was the 2000. So that's why 100 rupees was added to the 2000, not the 2050 rupees. That is a key point you have to keep in mind. Now this picture is clear. This concept is clear. This is the concurrent scheduling, because you are moving T1 to T2 or T2 to T1 and then T2 again go back to T1, and this process goes into our system as well. Now this is clear to all right now.
Sir,
Yes, sir.
I have a question.
Yes, tell me.
So what if we just omit the operation write A from T2?
T2, where I should do? Just can you tell me right now?
Write A, we just omit the operation.
You're talking about this point. So I'm highlighting with the yellow color. This is the point you're asking me right now.
So
Where? Can you tell me the operation so I can go to the
So in T2, write A.
right end? So this was the 900. Okay.
Yeah. If we just omit the operation, we cut the
Oh,
operation.
okay. You are saying we can omit this operation.
Yeah.
Okay, so no problem. You can omit. So what you can observe over here, we are trying to find the read A. So in this read A, in the transaction T2, read A is reading the value 1000 rupees, and temporary value we are getting the 100 rupees. So A will be the 900. But we are not using this value. We are omitting this value. So when we are moving to the T2 to T1, then when you will have to use. Just I am marking by circle, then it will be clear to all. When we are using this write operation over here, okay, so in this you can observe over here what is the value of the A is held by the transaction T1. So you can observe over here, you can observe over here what is the what is the value we have. So you can observe over here the what is the last value which is holding by the this transaction A, that was the 950. So while writing this A over here, so A will be considered as a 950 rupees only. So here A will be updated by the 950 rupees. If you try to omit this value, you mean to say that over here. So A will be considered as a 950 only. But if you do not want to use more write A operation over here, so you can leave, there will be no issue. So in this case, you can observe over here, in this case, in the T2, after writing A, we didn't use any one of the value of the A over here. So if you want to leave, then you can leave, but most of the case you have to keep in mind, then you will get the updated value that will be formed by the 950, not the 900. That is a point. Yeah, of course, you can leave, no issue. But keep in mind what was the last value of the A. So you can observe over last value after what is the last value inside the memory. Last value was the A equal to A minus 50, because that was the operation we have used inside the transaction T1. Last value was the memory in the 1000 rupees, and which was the data by the 50 only. This is a transaction. So after write, we are trying to use the write operation and the transaction T1, and we are omitting the write operation the T2. So definitely this value over will be over here 9,950 only, not the 900. But before that, before using the transaction T1 write operation, we have already used write operation, so it updated the A's value inside the memory, that was the 900. So that's why after using the write operation inside the T2, we will use a write operation the T1, then it is giving the updated value. So that was the 900. That is the reason. Now this is clear to all right now.
Yes, sir.
So see, I'm speaking once again. You have to keep in mind read means we are reading the value from the our database. And what is write operation? Write operation means what is the value we are writing on the disk. After the write operation, if you try to read the try to read the value by the any one of transaction, then it will give the updated value. That is the point you have to keep in mind. It's a simple example. After withdrawing the 10,000 rupees, but your amount was not updated so far by the bank. For a while, you can understand only. So after the banar, you will check your message. Oh, after the 10,000 rupees withdrawing, your account was not updated. Then again, you want to withdraw. Then you are able to withdraw. That is the policy. You are able to withdraw. But keep in mind, your after withdrawing your account should not be less than zero. So what is doing in the real time situation right now? The bank, what is doing right now in the bank? After detecting the 10,000 rupees from the account, immediately your account was updated due to the this online banking facility, or this is the core banking in our systems, banking system we have. That is the reason. But when talking about the 30 or 40 years ago, we didn't use the computer in the banking. We are just going to the manually, it was updated. So after 2 days, you will go to the bank, and then bank will update the bank balance in your passbook. So this is the reason. So now manually to computerization, we are changing the each and everything due to the immediately effect we can see. That is the only reason. Now this concept is clear. And this concurrent and serial schedule is clear to all right now, because there's a fundamental thing you have to keep in mind. Once you miss, then you can miss. Now let me know. This concept is clear. Just tell me
Yes,
that.
sir. Yes, sir.
Okay, good.
Yes, sir.
So this is again the entire theory we have over here. So I'm not going to the theory point right now. So the point we have to focus properly. If control of the concurrency execution, this is the point. So in the concurrent schedule we are using, in the concurrent schedule we have the concurrent execution of the transaction. If we control all these things, then we have to study a concept. This study concept is known as the concurrency control. So whenever you try to read any book, then you will find a topic that is a concurrency control. So what is the concurrency control? Concurrency control means a concept in which we have to control the concurrency execution of the transition. That is nothing else special. Okay. So for this we have our term. So right now I'm not going to the unnecessary. So what we have seen, a schedule is the order in which the operation of the multiple transition appear for the education we have discussed. Serial schedules are always consistent. We have to keep in mind how you can say it is consistent. Let me explain once again. In the serial schedules, what we are observing, either first transaction will execute complete and then transaction T2 will execute complete. But in the concurrent execution, transaction T1, neither transaction T1 nor transaction T2 was complete. That was the reason, because both belong to the inconsistent state. The transaction was started, begin, but not ended. So it will be in form of the inconsistent state. That is the only picture we have to keep in mind from the examples. Non-serial schedules are always not consistent. If we have a non-serial schedule, it means we're talking about the concurrent. Yeah, just you can understand. This is the point. Non-serial schedules means we are talking about the concurrent schedule. So concurrent schedules will be always inform the inconsistent, and to control these things, we have a topic which is known as the concurrency controls. Concurrent. Okay, so far we have discussed all these points. Let us move to the schedules in the database management system. Let us understand. Now, come to the point. Schedules in the database management system. So, first we have the serial schedules, we have seen. Non-serial schedules, we have seen the concurrent, we have seen. But in the serial schedules, it is also determined by the concurrent as well. But non-serial schedules also determined by the concurrent because we don't have the proper schedule. But in the database management system, non-serial schedules are represented by the different way when we have the conflictness. But here, see, while using the concurrent scheduling, if we are not having any kind of the conflicting of the transaction, then we can say it is not a we don't have any conflict. Then we can say it is a non-serial schedule, but it is a concurrent schedule. But in the concurrent schedule, if you have a conflict, then it would be part of the non-serial schedule under into the conflict serializability. That is the point. Let me explain once again. Schedule in the database management system, we have the two types. One is serial and other one is non-serial. In the serial schedule, we have seen the S1, S2, and S3, S4. So in the S3, S4 was the our schedules which are represented by the concurrent. If talking about the non-serial schedules, so we have the serializable. This serializable we have to start. When talking about the non-serializable, so we have the recoverable or non-recoverable. So recoverable can be expanded into the cascading schedule, cascade layer scheduling, and strict scheduling. But as per our syllabus, as per our concept, we will see only the serializable. So in the serializable, we have the conflict serializable and view serializable. So let us understand the conflict serializable first, and all this concept we will see through the our schedule respectively. So let us understand the serializability. So just serial schedules we have seen through the concurrent and serial schedules. Now let us understand the step by step this point. What is the serializability? Serializability is the process of the search for a concurrent schedule. Now here we have a term right now. I'm speaking once again. I already told you. So in the serializability, we have to focus on the concurrent schedule. Okay, so that is the point you have to keep in mind. Serializability is a process of search for the concurrent schedules whose output, it is written wrong, it is typing mistake. So whose output is equal to the serial schedule where transactions are okay transaction are execute one after the another. That is the point you have to keep in mind. Serializability is the process of the search for a concurrent schedules whose output is equal to a serial schedules where transactions are executed one after the another, and depending on the type of the schedules there are two types of the serializabilities. One is a conflict serializability, other one is view serializability. And right A and right B we have, so this is the point. So there are some rules we have to keep in mind properly. So from the rules I have from having the seen the rules, you will able to understand what is the steps we are taking. Now let me explain the things properly. So the differences you can anyone can ask into at the time of the interview. If you have studied the serial schedule and serial, so what is the difference between these two types of the schedule? So let us understand the thing over here. Serial schedules. Serial schedules cannot have the concurrency. Yes, of course. So S1 and S2 are our examples. In the serializable, we have the concurrency. Okay, that is the point. Because in the concurrency control, due to the concurrency controls, we have to understand the serializability. So we are trying to understand serializability or serializable schedule due to concurrency control, concurrency execution of the transaction. So the transaction necessarily executes serial one after the another. But in the serializability, what we have, the multiple transactions can execute concurrently. T1, T2, then T2, T1, T2. Second is difference we are getting. Serial schedules lead to less resource utilization and CPU throughput. But in this case, multiple transactions we are having. So then reusable schedule is saying to us maximum resource utilization will be because the transaction T1 we are reading again we are moving back to the, so context switching from one transaction to another transaction will take much time, which will utilize the resources. Here we are able to see only the one or two transition, then we will be happy to say, okay, so there will be no issue to use the more resources. But when talking about the lakhs and lakhs, thousands transition, then now see the how many times you will require to maintain all these things. So that is the point. So maximum resource utilization will be there and CPU throughput will be there. So that is the reason it will use the or it will improve the resource utilization properly, because resources are utilizing time to time. So that is a big point we have to keep in mind. After one transaction which is handed over to the another resource, so other transaction is followed by the another resource. So the previous resource was not busy to with the other process, and so there will be no use at that time the such resource. So that is the reason we can say the maximum utilization can be done inside the resource utilization. Now, serial schedules are less efficient as compared to the serializable schedules. So, due to the above reason, I have already marked over here this point. Due to the above reason, we can say serial schedules is not much efficient, while serializable schedule is always better because we have the maximum utilization of the resources. So, from this point, we have to keep in mind all the things properly. Let us understand. See how you can say that is the point, sir. How you can say resource utilization. So let me explain my answer. See, I can just mark this point right now. This is so transition T1 will not be used by the this time factor. This is the time factor. I can say T. And transition 2 will be busy with with our resources on this time factor. Same thing, it will be happen with the other transition. Other this is another time factor. This is a T. So the when the transition T2 was used with the resources at the time, the resource will not utilize the such a transition T1. So at a time we can say the resource is not compatible or resource will not be busy with the transition T1. So that is a not resource utilization for the transition T1 at that moment. So this is that is a time factor time T. So for the time T, transition T1 will not be part of the any resource utilization functionality. So that is the reason we have this one. So these are the differences. From this point, we have our conflict serializability. So let us understand the type of the serializability we have. So from the our diagram, We are cutting this sub part, serializability. So from the serializability, we have the conflict and view. So let us start the conflict serializability. Now this is the point. Yes. So for any doubt you have, so please you can ask. Yes, shall I continue? So far you have any doubt, so you can ask, or shall I continue?
Sir, continue.
Okay, thank you. So this is the time where we have the conflict serializability. So what is saying to us? If a given non-serial schedule, so now what is non-serial schedule? The schedule which can have the conflict scheduling. If a given non-serial schedule can be converted into a serial schedule, that is the point. So what we are doing actually, we are trying to convert. So due to the serializability is a process actually. Serializability is a process that is trying to convert your non-serial schedule into the serial schedule by the swapping its non-conflicting operation. So how you can do? So you need to find the some non-conflicting operation by which you can do. So you have the swapping operation. So swapping between the our transaction operation we can do, and it is also possible, but the outcome should not be changed. If it is changing, then there will be no sense for swapping. Then this is called this approach is known as the conflict serializability schedule. So what are the non-conflicting operations? That is a point you have to keep in mind. So before that, let's understand what are the conflicting operations. So we will use only the non-conflicting operation. If we are saying this is the conflicting operation, so we will avoid to use the conflicting operation inside the conflict seriality. That is the point. So two operations are called as conflicting operations. So what are those? Read-write operations. Okay. And if all the following conditions will be hold true for them, then we can say it is a conflict seriality. Let us understand. Both the operations belong to the different transaction. Both the operations belong to the different transactions. Okay. And both the operation are the same data item. Let me explain. Both the operation belong to the different transaction. Read X and WX. So this is a conflicting transaction. So I am trying to read the data item X, and same moment I'm just trying with the same transaction I'm also trying to write. So this is the conflict transaction. How I can see on the same moment, on the same particular time of the factors of the such transaction, I'm writing and I'm reading. So that is not possible. This is conflicting. So conflicting means a deadlock can happen. So both the operations belong to the different transactions. Write and write operation, write X and read WX. Not possible. Both the operations are on the same data item. So I'm using the same data item and I'm using the both the operations. Okay, same data item. So I'm using, so read and writing will not be happen. But I'm using the both the different operations, that is reading and writing. Different operations, I have the different transactions. So again, it will not be possible. All these things you can easily understand by the some example. It will be clear. I'm repeating once again. Focus on these rules. What are the conflicting operations? Both the operations belong to the different transactions. So transactions are different, but both are the operations that belong to the different transaction. So conflicting will be both the operations are on the same data item, just like writing the reading and writing operation on the same data item. So it will be happening. So it is just mark. Okay. At least one of the two operations is the right operations. So that is the point. At least one of the two operations. So two operations I have read and write operation. So that is the right operations. Again, I will have a conflict serializability or conflict operation I can have. Let us understand all these things by the our example. Conflict operations examples. Let us understand. Two operations are said to be conflict if all the conditions satisfied. They belong to the different transactions T1 and T2. Okay. So read A you can do. So both the transaction are reading the same data item at the time. So first I'm reading. Then after ending the read operation and read a data item by the transaction T1, With the next transaction also try to read, then again, then what happened? There's a conflicting, because once transaction ended, then you're trying to read, then again we have the conflict. They operate on the same data item, then again it will be conflicting. They operate on the same data item means if I'm using the read A and I'm using the write A by the other transactions, so again it will be happen, because one is trying to read, another one is trying to write operation. Now at least one of the them is write operation. Again you can say, if we are having the read operation and write operation, then again it will have the problem. So transition T1 and T2 will also have the different operation. Yeah, data item you can take, you can use the B, C, and D. Other data item you can take. So read A and read B also possible. So no conflicting will be there. That is non-conflicting operation. Read A and write B I can do. So at that time I can have the conflicting, because one of the operation will be the right operation. That will not be possible. So that is the point you have to keep in mind. Yes, example we have got the R1 A. So right A I'm just doing, and I'm doing the right. I'm doing the right operation on the A. They belong to two different transactions, but the same data item, that is the A. So one of them is the right operation. So I'm having the conflicting. Similarly, write A and write to two times I'm using the writing of the same data item. So that is not possible. So also the conflicting it is also possible. On the other hand, write A I'm doing a WA. So pair is non-conflicting because they operate on the different data item. That is the third one you can see inside the example part. Write, read A and write B. So read A I can do, write B I can do, because both the data item belong to different. So this is a non-conflicting operation. Write A I can do, WV I can do. It is a non-pairing because both are belong to the same data, same write operation, different write operation, because both data items are different. This is also the non-conflicting. But if data items are same, but if one of the them one of the operation belong to the right operation, so again we will have the conflicting. So these are the some rules we have to keep in mind. Now these rules are clear to all right now. Is it clear to all right now? All these rules are clear.
Yes.
Yes. So that's why all these things I have given inside the examples. Here we have the four important terms in the example, and this justify the our rules. So which are the non-conflicting and which are the conflicting operations. Let us understand this example over here. Can we say here we have a conflict serializability? Say yes or no? Yes, because transaction T1 using the W1 or right, that is write one operation on the A data item, but transaction T2 use the read A operation, read two operation on the A. So read operation I'm having over here. So on the same data item I'm having over here, and one of the these two operation, one operation belong to right operation. So that is the reason we have the conflicting. So conflicting operations we are having. So this is the conflict serializability we can have. Now this is the point. This example is clear right now. Just tell me. This example is clear.
Yes, sir.
Okay. Swapping is possible only if S1 and S2 are the logical equal. Yes, that is a possible. So here S1 and S2, that means these are the two non-conflict schedules we have over here. So T1 and T2 we have, so T A read B. So swapping can be done like this one. So we can swap the operation like this. So schedule 1, schedule 2 are the two schedules we have over here. We can do the swapping, but keep in mind logically equal. Logically should be equal. If it is they are logically equal, then swapping can be possible. So swap is done like this one. So as I told you, the swapping you can swap the your transaction. You can swap the operations. You can swap the two different operations. But keep in mind, if you are there providing the logically equal operations. So that is the point. Here we can say the two different we have read A and write A. So two different operations we have. One is read, another one is write. But data items are the same. So swapping, if I try to do, it will not be possible. So that means it is conflicting. Okay. So read A, read write A, I can do. So the swapping will not be possible over here. Now these two examples are clear. Yes, tell me. These two examples are clear. First one is now this is non-conflicting because we have the same data item, but we have the same data of the same operation as well. So swapping we can do logically, but after logically the sense we should have the same sense. But here we are founding over here. If you're trying to do something like this one, read A, write B. So two different data operations we have. So definitely what we can say here, conflicting can exist. How you can say it is simple, no? One of data item belong to write operation. So how you can do the swapping because one of the data item one of the operation belong to write operation. So that is a conflict we have over here. It simple means swapping will not be possible due to the conflictness. Now clear? Now this example is clear. See this example is similar to like this. W1A and R2A. So because one of the operations belong to the right operation and that will not be possible. See, third operation, third statement. At least one of them is right operation, so it will be the conflicting operation. So this was our example, which is inspired by the previous ones. Now, can you just tell me, is it clear?
Excuse me, sir.
Yeah, just tell me.
So I have a doubt. Means if transition T1 is executing first read A,
Okay.
and after that the processor shift to T2, means T1 is in waiting state right now.
Yes.
Then how conflict occurs? Means they are not executing concurrently, sir. First T1 execute, then it goes to waiting state, then T2 execute, and again if there is again T1, then T2 will go to waiting state, and then T1. Then how
Okay.
there is a
Okay. I got your questions right now. Just again look at this point right now. Look at this is the important point. You are thinking about like this one, sir. This is the T1 is using this time, but in the non-concurrent see, this was the serial. But when talking about the non-serial case, the once transition T1 was started, before ending the transition T1, we are switching. So you are switching to the transition T2. It means transition T1 was not ended. Its time for executing was started. So it is inside in the memory. That was my point. Just look at this concept in terms of the operating system as right now. If one process is executing before ending its execution, you're trying to insert a new process inside the memory. Then the process P1 was not ended, and the process P2 was trying to insert. Then at a time in the memory, both processes will be. So that is the point. So that is the reason. Now come to the point right now. So in this case, if transition T1 and T2 we have, so this is only the small chunk part of the our schedules we have over here. But you have to keep in mind transition T1 also in the part of the memory right now, and suddenly we are trying to perform the read operation or write operation in the transition T2. So if you try to perform the same operation on the same data item, then again you can say it is non-conflicting because you are trying to read the operation only, perform read operation. But on the same data item, both transactions are inside the memory and try to perform the different operation. So conflict will be automatically, and this is a natural process. Now clear right now this term?
yes, sir, inconsistent will be there.
Yeah, definitely it should be. So that is you are on the right track. Inconsistency will be there. Now this picture is clear. This diagram is clear.
Yes, sir.
Okay. So let us understand this example. Just look at this example I have already showed. So this one example, schedule one is non-serial and the other one is serial. So schedule S2 is a serial schedule because in this case, all operation of the T1 are performed before starting any operation of the T2. This is the thing we have seen. And transition T, just look at the first serial. Just look at the right side part serial schedules. It is already mentioned over here. Write we have and read B. Write B and read A we have. So both data items we have. Both data items we have. So different data items we have. So it will not be conflict. Okay, that is the point. But in the non-serial, you can see the write A and read B. So you are using same data item. There will be no issue. but one of the operations belong to right, so it is a conflicting. So that is the point. Now clear, this picture is clear. If I compare the non-serial and serial, so this picture is clear right now.
Yes, sir.
Yes. Okay. So if I'm trying to swap over here, right B, I can swap read B, read A, I can swap. So swapping is possible. Where it is possible, where is not possible. So this is the part. So this is the chunk of the our schedules we have taken from the previous slides, like this one and this one. Okay. So now this is the correct example. Now let us move to the next example. Don't need to discuss more over here because we have seen all this part. This is a summarized example. Now, after swapping of the non-conflict operations of the schedule S1, this is the schedule S1. In the schedule S1, after performing the swapping operation of the non-conflict operation, the schedule S1 becomes, since S1 is conflict serializable. So now we have done the swapping. It is visible to all right now. Since S1 is a conflict serializable. Read A, read A. Transition T1 using the read A, read A. Transition T, read B, read A, read A. Transition T1 again, read B, read B. Transition T2, read B, read B. Now you can swap. Now where swapping is possible? Where swapping is possible? So we have done the swapping. So after swapping, we will got the answer. Can anyone tell me right now how we did swapping? Look at this non-serial schedule and tell me how and where we did the swapping. Just tell me right now. Tell me where we did the swapping.
So can you show the result of the swapping?
Yes, is the result. It's a just have a glance and see the result and have a just only glance and tell me.
Sir, in transition T1, the read B and write B swap with first instructions of T2 means read and write A.
Hmm. Okay,
Then
anyone? Okay, you are on the right track. Anyone who have different idea because you are on the right track. Okay, I just can highlight the point where we can swap. It's simple. Just if I'm marking is wrong, so just let me know right now. Look at read B and write A. Is it conflicting or non-conflicting?
non-conflict.
Non-conflicting.
So can we swap?
Yes, sir.
So see, this is the okay. And now write B and read B. So here we can the conflicting. But if talking about this will read B just become the swap, so it will be on the upside, and write A will be downside. So write A we can do, but here we found that there are both different operation. So but it will be found over there. Write B will be close to the read A right now. So read A, just read A. So read A, write B. So again we will have non-conflicting. So swapping will be there. So we have to find the point where we can do the swap. So this would be the brother. So these are the our. We have performed our swapping between these operations. Now, it was a very simple answer. Now it is clear to all right now.
Yes, sir.
Okay. Any doubt from the this class? You have any doubt so far?
Clear, sir.
Okay. Okay, students.